Dear students, in the previous video on electrostatics, I have discussed Coulomb's law, the electrostatic forces, electric field and superposition principle. I have also discussed two numerical problems based on superposition principle, and in this unit we will take up some more numerical problems. So let me begin with the first one, the numerical based on superposition principle. Now dear students, it is difficult to make PowerPoints due to involvement of many equations. So I have picked up the picture as it is. So let us take up this first problem. You can see a picture where two charges, you can see one charge 5 microcoulomb and another one minus 1 microcoulomb are placed 40 centimeter apart, and according to the question you have to calculate the force acting on 2 microcoulomb charge, right? So now and the charge is placed midway between Q1 and Q2. Now the distance between Q1 and Q2 is 40 centimeter and this charge 2 microcoulomb is placed exactly midway between them. Now you can see that the force between Q1 and Q both are positively charged, so it will be repulsive force. So Q will experience a repulsive force along this direction. You can see that F1 is away from charge Q1. Now the force between Q and Q2. Now since one is positive, other one is negative, it is going to be attractive charge. So Q2 जो है Q को अपनी तरफ खींचेगा, attract करेगा. You can see the second force. So both the forces F1 and F2 are along the same direction. You can see that both the forces F1 and F2 are acting along the same direction. So the total force will be vector sum of these two forces. Now as these two forces are acting along the same line, we can simply add them. So first we'll write the relations for them. So the force between Q1 and Q, force between Q1 and Q is given by this relation 1 upon 4 pi epsilon naught Q1Q upon R square, and the force is repulsive. Force between Q and Q2, Q and Q2 is F2, and here 1 upon 4 pi epsilon naught Q2 upon R square, and it is attractive force. Now the forces F1 and F2 are along the same direction, so the resultant force will be F1 plus F2, and since they are along the same direction, so direct addition will do. यहाँ पर हमें वेक्टर सम लेने की ज़रूरत नहीं है, सीधे सीधे algebraic sum से हमारा काम चलेगा. Now you can see adding these two equations, you can see adding this equation and this equation, I can take 1 upon 4 pi epsilon naught common. Here you can see that Q is present in both the equations, so Q upon R square, Q and R square also, I have taken them common. Now from the first equation only Q1 is left, and from the second equation only Q2 is left. So inside the bracket I get Q1 plus Q2. Now the distance R between these two charges is 20 centimeter, and we have to take them in SI units, so it is equal to 0.2 meter. Now putting all these values, now the value of 1 upon 4 pi epsilon naught is, this is 9 into 10 to the power 9. The value of Q is 2 micro, and you know that micro is 10 to the power minus 6. So 2 micro coulomb, 10 raised to the power minus 6. R is 0.2 meter, and it is 0.2 meter whole square. Now inside the bracket, one charge is 5 microcoulomb, so 5. The other one is 1 microcoulomb, so 1. and micro 10 raised to the power minus 6 is common in both of them, so I have taken it as common, right? So now calculating it, the final result comes out to be 2.7 Newton. Now let us look at the direction of this force. See, since both the forces are along the same direction, so direction is towards the charge Q2, towards the negative charge. Let us have a look at this diagram once again. See, the resultant force is acting towards the negative charge, towards Q. Sum of F1 and F2 will be acting towards Q, right? So while solving such numerical problems, you have to keep in mind that everything should be taken in SI unit first thing, and you can always make your work easier. Like I have taken relation for F1, F2 and directly added them. Now if you try to do them separately, first you will calculate say F1, then you will calculate F2, and then you will add them, and all this will take longer, more of calculation and more of your time in examination. So you must learn to simplify your numerical problems. So let us take another problem based on superposition principle only, but here the forces are not acting along the same line, so we'll have to take their proper vector addition. So now the problem is like this: 3 charges, 50 microcoulomb, 50 microcoulomb and 2 nanocoulomb are placed at 3 vertices of an equilateral triangle of side 5 centimeter, right? Calculate the force acting on 2 nanocoulomb charge. So let us look at this one. You can see this diagram. We have first charge Q1 as 50 nanocoulomb, 50 microcoulomb. Second charge Q2 as 50 microcoulomb. Third charge Q is 2 nanocoulomb. And equilateral triangle with the side 5 centimeter. These informations are given to you. Now, this charge 2 nanocoulomb will experience force due to each of the charges 50 microcoulomb as well as 50 microcoulomb. So now the force on this charge 2 nanocoulomb due to 50 microcoulomb will be repulsive force. They both are positive charges, and the force will act along the line joining the two charges, as you can see, right? Similarly, the force on this 2 nanocoulomb due to this 50 microcoulomb, now again they both are positive, so the force will be repulsive, or repulsive force will act along the line joining these two charges. So direction of F2 is going to be this one. Now in this way, we have two forces F1 and F2 acting at the same point, acting at the same charge 2 nanocoulomb. So the resultant force will be vector sum of F1 and F2. So we need to find out their vector sum. Now one more thing to see is that Q1 and Q2, this charge and this charge, they are equal. So both these forces will be equal in magnitude, and the separations are also equal. It is an equilateral triangle. So both the forces will be equal in magnitude, but directions are different. So let us see how we do it. Okay. So now charge 2 nanocoulomb is equidistant from 50 microcoulomb, and so the forces, see, magnitude of F1 and magnitude of F2 are equal. Now force F1 is given by this relation, as you can see. Force F1 will be given by this relation, 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Now the value of 1 upon 4 pi epsilon naught, 9 into 10 to the power 9. Value of Q1 is 50 into 10 to the power minus 6. Micro है 10 to the power minus 6. Q is 2 nanocoulomb. So 2 as it is, and for 2 as it is, and for nano we have 10 to the power minus 9. Now, the distance between the charges is 5 centimeter. So first you convert centimeter into meter, and centi means 10 raised to the power minus 2. So 5 into 10 to the power minus 2, और r square है तो इस पूरे का square भी करना है. So putting all these values and simplifying, you get F1 is equal to 0.36 Newton, and this F1 is equal to F2 only, same magnitude, right? So now we have two forces F1 and F2, and again let us look at this diagram. F1 and F2 are acting at 60 degree. You can see it is an equilateral triangle, so all the angles are equal to 60 degree, and if this is 60, then this is vertically opposite angle, 60 degree only. So the angle between F1 and F2 is 60 degree. We have two vectors acting at 60 degree. So now the resultant force, you have done this relation, is F is equal to under root F1 square plus F2 square plus 2 F1 F2 cos 60. And then putting the values, let us assume that each of the force is equal to A. Then F1 is equal to A square, F2 is also A2 A square plus 2 A into A, and cos 60 is equal to 1 upon 2. Now this 2 and this 2 cancel out, and we get A square plus A square plus A square. So under root 3A square, and from here A is taken out, we are left with A under root 3. Now I can put the value of A, and we have just done the calculation that A is equal to 0.36 Newton and up into root 3. Now I have left it at this place only, but you can multiply by the value of root 3, which is 1.71, and then you can do the relation. Now let us come to the direction of this force, because force is a vector quantity. So only telling the magnitude is not sufficient. We need to find out the direction of this resultant force also. So here you can see that F1 and F2 are equal forces acting at 30 degree, acting at 60 degree. So it's very clear that first we need to complete the parallelogram. See, I have completed the parallelogram, and the line, the diagonal starting from this is going to be the resultant force. And since it is F1, F2 are equal, so the angle between these two has to be equal. So therefore, the resultant force, you can see, the resultant force will make equal angles with each one of them. And if it is making equal angle, and if I try to produce it backwards, it is going to be along this, its median only, perpendicular bisector. Therefore, we can say that the resultant force is acting along the median, and it is outwards. See, acting along the median and outwards. It is acting along the median and outwards. This is the resultant force acting on this charge 2 nanocoulomb. So that is how we solve problems based on superposition principle. So sometimes the forces are along the same direction, along the same line. Then you can always take their algebraic sum. But if they are not along the same line, you need to take up these vector additions. And there are many such possibilities. Now, the next one, a very simple problem, but it is also an important problem only. It is based on electric force and electric field also. So here, let us read out the question only. An oil drop of mass 1 microgram having 12 excess electrons is held stationary in uniform electric field under effect of gravity. Find the magnitude and direction of electric field. The value of G is given to be this much. So it is like आपके पास एक oil drop है, उसके पास 12 extra electrons है. It means कि इसके पास नेगेटिव चार्ज है क्योंकि इसके पास एक्सेस इलेक्ट्रॉन है और वो हवा में आराम से स्टेशनरी है, रुका हुआ है. तो द फोर्स ऑन दिस ऑयल ड्रॉप विल एक्ट, its weight will act downwards, as you can see here. mg is acting downwards. अब ये क्यों हवा में रुका हुआ है तो इसके ऊपर फोर्स लगना चाहिए, वही फोर्स इसको बैलेंस करेगा. सो दैट मीन्स दैट द फोर्स एक्टिंग ऑन इट हैज़ टू बी इन अपवर्ड डायरेक्शन. सो द इलेक्ट्रिक फोर्स acting on it is in upward direction, right? And you know that the force on a negative charge is always opposite to the direction of electric field. So if the force is in upward direction, then direction of electric field has to be vertically downwards. So the electric field is acting vertically downwards. So the direction of force is the direction of electric field and direction of forces are very clear now. Now the forces, electric force and the gravitational force, that is the weight, they should be equal and opposite. So let us try to solve. Now electric field is vertically downwards. Now force mg, force F is equal to mg, but F is equal to QE also. You have already done it. F is equal to QE, relation for force acting on a charge in electric field. So mg should be equal to QE. Now we can solve it by putting the value of m. Now mass is 1 microgram. So for micro I have this 10 to the power minus 6, right? And for gram it is in gram और SI unit में convert करना है kilogram. So you have to divide it by 10 raised to the power 3 also. The value of G is given to be 10 meter per second square. Charge Q is NE, quantization condition. और हमको पता है कि इसके ऊपर 12 इलेक्ट्रॉन्स है तो N की वैल्यू 12 है, right? Now solving this we know the value of N and we also know the value of E, charge on each electron. So we can put their values and we can find out the value of electric field. So now here, see, 12 electrons, charge on each electron is this, E is equal to 10 to the power minus 8. Now E is equal to, इन सब से इधर हमने divide कर दिया, simplify करके you can find out the value of the electric field. It's a very simple question and you must have done Millikan's oil drop experiment. So this relation is based on that one only. Now another problem based on superposition principle only, but in this case we will talk about electric field, not the electric forces. And these both the problems are of board examination only. So let us look at the this problem first. Find the position of a point for the line joining two charges where electric field is 0. See, electric field is 0. We have two charges, 4 microcoulomb and 9 microcoulomb at distance r, and we have to find out a point on this line. On this line joining these two charges where the electric field is 0. So one condition is this one and another one is this one. We have this 4 microcoulomb here and minus 9 microcoulomb here, and we need to find out a point where electric field is 0. So these are two different problems. So let us begin with the first part. Okay, you can see this part. Okay, so 4 microcoulomb here and 9 microcoulomb here, and at the mid let us assume that the point is placed at distance x from 4 microcoulomb. You can see that the distance is x from 4 microcoulomb. So the remaining distance will be r minus x. Now, you know that electric field is always directed away from charge, directed away from positive charge. So electric field due to 4 microcoulomb is E2, directed away from it. Electric field, okay, E1, let me consider as E1. An electric field due to 9 microcoulomb will be directed away from it, say E2, right? Now magnitude of E1, since the electric fields are up in opposite directions, and net electric field at this point has to be 0, that means magnitude of E1 and E2 should be equal. So we can write their relations, right? Now the formula for electric field is 1 upon 4 pi epsilon naught q upon r square. I'll write it here, 1 upon 4 pi epsilon naught q upon r square. This is the relation for electric field. So due to charge 4 microcoulomb, the electric field is 1 upon 4 pi epsilon naught 4 into 10 to the power minus 6 micro है upon x square is equal to 9 into 10 to the power minus 6 1 upon 4 pi epsilon naught into r minus x square, as you can see. So दोनों साइड जो कैंसिल होता है कैंसिल कीजिए, एंड इस साइड में यू आर लेफ्ट विथ 4 अपॉन एक्स स्क्वायर. राइट साइड में आपके पास बचता है 9 अपॉन आर माइनस एक्स स्क्वायर, ठीक है, एंड टेकिंग स्क्वायर रूट ऑफ बोथ द साइड्स 2 अपॉन एक्स, राइट साइड 3 अपॉन आर माइनस एक्स, क्रॉस मल्टीप्लाई कर लीजिए, 2r minus 2x is equal to 3x. Again change the sides, you can see that 3x and 2x राइट साइड में ले जाएंगे तो ऐड हो जाएगा 5x. सो 5x इज इक्वल टू 2r और x इज इक्वल टू 2 अपॉन 5r फ्रॉम 4 माइक्रोकूलम. सो द पॉइंट लाइज एट 2 upon 5r from the charge 4 microcoulomb. You can see that. So we can tell the exact position of this charge. So such problems should be solved in this way only. Now, okay. So the next part. Here you can see. Now, if one charge is positive, like this one, and other charge is negative, then it is just not possible to have any point between the lines. If I choose any point here, then electric field due to 4 microcoulomb will be away from it, and electric field due to minus 9 microcoulomb will be towards it, and they will be added up. So यहाँ से यहाँ तक कहीं भी आपको ज़ीरो इलेक्ट्रिक फील्ड मिल ही नहीं सकता, तो हमको इस लाइन से बाहर आना पड़ेगा. अब बाहर आएंगे तो दो पॉसिबिलिटी हैं, या तो हम इधर लेफ्ट में चले जाएं या हम राइट में चले जाएं. जब हम राइट में जाएंगे तो इलेक्ट्रिक फील्ड हमेशा -9 की वजह से ज़्यादा ही बना रहेगा, क्योंकि इलेक्ट्रिक फील्ड -9 कूलम का ज़्यादा होगा और +4 माइक्रोकूलम का कम रहेगा. तो किसी भी कंडीशन में राइट साइड में जाके तो आपको ज़ीरो इलेक्ट्रिक फील्ड मिल ही नहीं सकता. सो द ओनली पॉसिबिलिटी लेफ्ट इज दिस लेफ्ट साइड, राइट. तो लेट अस अज्यूम दैट द पॉइंट लाइज एट डिस्टेंस x फ्रॉम 4 माइक्रोकूलम, एंड नाउ द डिस्टेंस ऑफ दिस पॉइंट फ्रॉम 9 microcoulomb will be r plus x, as you can see, r plus x. ठीक है. Now, electric field due to 4 microcoulomb will be directed away from it, E1, as you can see, and electric field due to -9 coulomb will be directed towards it. हमें इलेक्ट्रिक फील्ड ज़ीरो करना है, नेट इलेक्ट्रिक फील्ड ज़ीरो करना है, तो इन इलेक्ट्रिक फील्ड्स का अपोजिट होना बहुत ही ज़रूरी है. ठीक है. और ज़ीरो तभी होगा जब दोनों के मैग्नीट्यूड्स बराबर होंगे, मतलब मैग्नीट्यूड्स बराबर और डायरेक्शन अपोजिट. ठीक है. सो हियर वी गेट दिस कंडीशन, मैग्नीट्यूड ऑफ E1 शुड बी इक्वल टू मैग्नीट्यूड ऑफ E2. यहाँ फिर हम वैल्यूज़ डाल सकते हैं. नाउ जो हमारा E2 है नेगेटिव चार्ज की वजह से है, वो 1/4πε0 इंटू 9 इंटू 10⁻⁻6 अपॉन r प्लस एक्स स्क्वायर और 1/4πε0 10⁻⁻6 अपॉन एक्स स्क्वायर. ठीक है, जो कटता है काटिए, कैंसिल आउट, एंड देन टेक द स्क्वायर रूट. सो 9 का स्क्वायर रूट 3, r प्लस एक्स स्क्वायर का स्क्वायर रूट r प्लस एक्स. आई गेट दिस. राइट साइड का स्क्वायर रूट लोगे तो 4 का हो जाएगा 2 और एक्स स्क्वायर का x. और अब आगे यू कैन चेंज द साइड्स, क्रॉस मल्टीप्लाई कीजिए 3x और 2r प्लस 2x, और 2x को लेफ्ट में लेकर आ जाएंगे तो 3x माइनस 2x विल बी x, नाउ x इज इक्वल टू 2r. सो इसका मतलब ये हुआ कि नाउ द पोजीशन वेयर द इलेक्ट्रिक फील्ड इज ज़ीरो, द पोजीशन वेयर द इलेक्ट्रिक फील्ड इज ज़ीरो lies at distance r from 4 microcoulomb and at distance 2r from -9 microcoulomb. ठीक है. So before attempting such questions you must look at the possibilities where the electric field is going to be zero. It is a very important problem and it is often asked in examination. So thank you.